This is the screencast for section 2.2, example 9. So believe it or not, we can investigate the graph of y equals f of x as x approaches positive or negative infinity by investigating the graph of f of 1 over x as x approaches 0. If we look at f of 1 over x as x approaches 0, maybe f of 1 over 1, f of 1 over 0.1, f of 1 over 0.0001, etc. If you take 1 and divide by a really tiny number, you're eventually going to be plugging in infinity. So we can look at x approaching infinity, or we can look at x approaching 0 of 1 over x, which is also just another way of showing infinity. So example 9 here says find the limit as x approaches infinity of the sine of 1 over x. So in our situation, f of x itself is the sine of 1 over x. I graphed that one here just so you can see, and we're trying to find the limit as x approaches infinity. Okay, well, as x approaches infinity, you know that 1 divided by a number that gets bigger and bigger and bigger would be 0, and the sine of 0 is 0. Graphically, you can also see that that approaches 0. Well, let's take a look then at f of 1 over x, and that would be the sine of 1 over x, which is the sine of x. So the limit as x now approaches 0 of sine of x is, and you can just substitute in the sine of 0, which is 0. The now try problem number 49 says use the graph of y equals f of 1 over x to find the limit as x approaches positive infinity and the limit as x approaches negative infinity. Well, f of x is x times e to the x. So f of 1 over x is going to equal 1 over x times e to the 1 over x. To separate the idea of finding the limit as x approaches positive infinity versus x approaches negative infinity, that's where your limits from the left and from the right come into play. If we want to find the limit as x approaches positive infinity, we're going to find the limit as x approaches 0 from the right of f of 1 over x. So 1 over x e to the 1 over x. And I can separate that into the limit as x approaches 0 from the right of 1 over x times the limit as x approaches 0 from the right of e to the 1 over x. Well, 1 over x, as x becomes really close to 0, so if I'm taking 1 and dividing by a really tiny number, I'm going to get infinity. Also, graphically, you know the graph of 1 over x, its limit as x approaches 0 from the right is positive infinity. Now the limit as x approaches 0 from the right of e to the 1 over x, well, we just said that 1 over x as we approach 0 from the right would be infinity, so it's kind of like e to the infinity. So the limit as x approaches 0 from the right is positive infinity. And I can see that here. Here's my f of 1 over x. As I come in towards 0 from the right, my y values go up to positive infinity. So now to find the limit of f of x as x approaches negative infinity, we'll look at the limit as x approaches 0 from the left of 1 over x. So 1 over x e to the 1 over x. I split those two up using my limit properties. And now the limit as x approaches 0 from the left, we're going to take 1 and divide by really small negative numbers. So numbers really close to 0 but still on the negative side. So that will approach negative infinity. Just like the graph we drew over here. Of 1 over x, as we approach 0 from the left, we go down to negative infinity for the y values. Then e to the 1 over x, as we get really close to 0 from the left, we'll have e to the negative infinity, and e to the negative infinity would be 1 over e to the infinity, so something really large, which would then be 0. 0 trumps infinity. 0 times anything is 0, even infinity. we have not yet found the limit as x approaches infinity of f of x, or the limit as x approaches negative infinity of f of x, so we have to make those statements. We only found the limit as x approaches 0 from the left or right of f of 1 over x. So now, with my statement as x approaches 0 from the right, I can conclude that the limit as x approaches infinity of f of x is infinity, and the limit as x approaches negative infinity of f of x will be 0.